All right. My name is Aaron Lee. I'm the contact PI for our Salutogenesis data generation project. This is just an overview of what we're going to go through in these brief 10 minutes I have with you. So if you are not familiar with the term salutogenesis, then you can simply think of it as the opposite of pathogenesis. It's the process in which the body kind of returns to a healthy state. We spent a lot of time and effort in biomedical research trying to slow down or halt the march towards disease, but we haven't spent a lot of time thinking about how to bring people back to a healthy state. And so that's the goal of our project, is to collect a data set that would unlock the ability to study the process of salutogenesis. One of the things that's sort of unique about our project is that we really have data from head to toe. And we really have sort of a multi-scale data set, all the way from whole genome sequences all the way up to retinal images and EKGs. Our data collection protocol that we're trying to collect about 4,000 participants in is fairly extensive. So we have about a 1 hour pre-visit survey section where they have to fill out many different surveys at home. There's a 3 to 4 hour on-site visit where we collect many different protocols on them, including blood tests where we check many different markers of diabetes. We bank their blood as well at University of Alabama at Birmingham. And then we send them home with 3 devices. We send them home with a continuous glucose monitoring device, a fitness tracker, and a custom-built environmental sensor. And the idea is that we would get a biophysical profile of what they're like at home for about 10 days, and then they mail the devices back to us. In terms of data releases, we had our initial release of our pilot of about 200 participants back in May of last year. By the time we got to around August, we had about 1,000. We froze our data set, we prepared it for release, and in November, we released our version 2 of that data set. This data set is live and available on our website. You can go through our attestation and register for it, and then actually download it to your computers. So the year 2 data set of 1,000 participants, which is about a fourth of our total target, has all these different measurements in it, many millions of measurements of their glucose and heart rate, as well as the particulate matter inside of their homes, and many different forms of retinal imaging. Altogether, it's about 2 terabytes of data. And I've never thought I would get complaints of having too much data from data scientists, but they are complaining that this is too much data. And so we're going to, in the future, release a smaller version that people can download easily to their computers. In terms of data transferred from our project, this is a graph that shows the amount of terabytes that have gone out from our website. We're reaching almost 500 terabytes of bandwidth that we've accumulated. The number on top here is actually the number of research groups. On the previous slide, you might have noticed that we've actually crossed 500 research groups that have downloaded our data set. These are some of the very first papers that we've spotted in the literature of other groups outside of our consortium using this data set for research. And these are full text research articles of 2 different groups using this data set to train deep learning models. And then there was 1 abstract at a conference as well. And we're hoping that 500 will translate to many more papers in the future. We built this sort of visualization tool to help people understand what our data set looks like of the 1,000 people. So each dot is 1 participant. They're colored by the different diabetes severity. They're sized by the decade of life. And so you can sort of see that there's an even distribution across the different severity types. We have our 3 clinical sites of UAB, UCSD, and University of Washington. And one of the things that we felt sort of strongly about is providing splits of the training, validation, and tests, so that when people use this data set, if they follow these partitions, then you can directly compare performance across different papers. We have basically 100% of clinical data available almost 99% of EKGs available. One of the devices is a research device called FLEO, and it broke down, which is why we are missing some. But for all the other modalities, we really have a near complete data set. For data dissemination, we have the Swiss cheese model of open data sharing, and we'll go into a lot more of that this afternoon if you come to our Meet the Grand Challenges. This is what it looks like in terms of our breakdown of demographics. We are aiming for equal numbers across these. So these pie charts, by the time we get to the end of the project, should look even across all these dimensions. In terms of our future releases, by November of this year, we're hoping that we'll have data on about 2,600 participants. We're also hoping to have whole genomes on that the same number by around that time. And by November of next year, we'll get up to 4,000 and have EHR data as well. Just a quick show of hands. How many of you have trained a computer vision deep learning model? Raise your hand. Okay, and keep your hand up if you have also used federated learning to train a deep learning model. So very much fewer. Okay, so if you come to our workshop this afternoon, you will get to do both of those things. We have GPUs for every single person who comes to our open house this afternoon. And we'll walk you through training a computer vision deep learning model, as well as break you up into groups of 3. And this is out of our partnership with Palisade X. We will get everybody in groups of 3 to do federated learning. So we hope that we'll see you this afternoon. Thank you.